Hello students, today we are going to study the third topic of chapter number 11 of our class 10th science NCERT textbook. This would be the last session of this chapter. Now, already we have covered the topics human eye, accommodation of eye defects. So, today we are going to study dispersion, atmospheric refraction and scattering. In the last session we already studied the basic about refraction. So we will continue from that topic itself. So as we studied in the last session that refraction through prism. Prism is a piece of glass or any transparent material which is bounded by triangular and three rectangular surfaces. As we saw that day, this is a prism. This is a prism. It is bounded by a triangular and three rectangular surfaces. As you can see that it has three rectangular surfaces. Now, the rectangular surfaces are also called as refracting surfaces. And the angle between the two refracting surfaces is also called as refracting angle or angle of prism, which we already learnt in the last session. Then the line along which the two refracting surfaces meet is called refracting the edge, and any section of prism which is perpendicular to refracting edge is the principal section of edge. This we have studied in the last session. Now, here as we saw that we saw the refraction through a prism. Here the light ray is coming. As we know, this is the incident ray and this is the refracted ray and this one is the emergent ray. Okay, now what happens here? The ray of light is entering from air to the glass surface. Air enters from air to the glass surface at the first surface. This is the first surface. So light ray enters from the air to the glass surface, to the first surface. Okay, now the light ray on refraction. Here the light ray refracts. So this is known as the refracted ray. This is the refracted ray. Here this is the incident ray. So this angle is known as angle of incidence and this is the angle of refraction. So here the light ray on refraction has bent towards the normal. It bent towards the normal. This is the normal. So it bent towards the normal. Now, then what happens? And here, so after refraction, the second surface, that is AC, this is the second surface. This is second surface, and the light ray has entered from glass to the air. Then it moves out. That is, it goes again to the air. So this is the our emergence, angle of emergence. This is the emergent ray. Hence it bends away from the normal. Now the peculiar shape of the prism makes the emergent ray bend at an angle of the angle to the direction of the incident ray. What happens here? The angle of emergence. Then here these angles meet, two angles, and from here the light ray enters in this direction as they meet here. So this is the angle of deviation. Angle of deviation. I hope that I am clear to you. Angle of deviation. Okay. Now, in case angle D is the angle of deviation, this is the angle of deviation. Okay, so this is also done. This is the refraction through a prism. I hope that I am clear. Here the light ray enters from the air to the glass. So this is the incident ray. It incidents on the surface. So this is the angle of incidence. Then here it refracts through the glass slab, or we can say the glass prism. So this is the refracted ray and the angle is the angle of refraction, and here it emerges. So it is the angle of emergence and it moves away from the normal. So here the points meet and so the light ray deviates in another direction. So this is the angle of deviation. I hope I am clear to you the refraction through a prism. Now let's study about dispersion. Dispersion basically is a phenomenon of splitting of light into 7 colors. It is the splitting of white light into 7 colors. It's just a simple phenomenon. When white light strikes a glass prism or any glass surfaces, we can say it splits into 7 colors. This is the spectrum. We term this 7 colors, this splitting of light into spectrum, as spectrum. That is, we can term them as VIBGYOR, which is an easy acronym that will help you to remember it easily. VIBGYOR, that is violet, indigo, blue, green, yellow, orange and red. So let's study this in detail. This was just a simple definition. Dispersion is defined as the phenomenon of splitting of light into 7 colors. Now, you might have seen and appreciated the spectacular colors in a rainbow. How there are different colors which are represented in a rainbow. So, the prism has probably split the incident white light into a band of colors. Prism is also simply that thing. It has probably split the incident white light, the white light that is incident, that is coming, it splits it into bands of colors, that is, it splits it into bands of 7 colors. So let's see, when light, that is sunlight or bulb light, is allowed to pass through glass prism, it splits into 7 colors. As I told you in the previous slide also, that when any white light is allowed to pass through a glass prism, it splits into 7 colors, and it split because we know white light is combination of 7 colors, and each color on entering into prism get refracted by different angle, due to which different color is obtained on screen. Why this happens? Because we know that white light is a combination of 7 colors. When we combine 7 colors, it becomes white light, or when 7 colors are combined, it becomes white. So when each color enters into the prism, it gets refracted by different angles. See, here we can see that these are refracting in different angles, and due to which different color, that is spectrum, is obtained. So that due to this only different colors are obtained on the screen. If they refract at a similar angle, only if they refract at only one angle, then only one type of color we would get. But here they are refracting at different angles, and due to this only we are getting different colors are obtained on a screen. And the different colors obtained are red, orange, yellow, green, blue, indigo and violet. Okay, so as we go from violet to red, the wavelength decreases and frequency increases. See, both are opposite. As we move from violet to red, the wavelength decreases and frequency increases. So the frequency of red color is more and wavelength is least. Okay, so the band of the colored components of a light beam is called its spectrum. As I told you that these 7 colors we term as spectrum, or this splitting of light into colors, these different colors, these band of colors we call as spectrum. Now see here, red color is least deviated and violet color is the maximum deviated. As we can see it clearly that this red color is least deviated and violet color is most deviated because it reaches till the end. So as we can see here, white light is dispersed into its 7 color component by a prism. But why do we get these colors? So as we know that different colors of light bend through different angles, as I told you in the previous slide. Different colors of light bend through different angles, and so that's why we are getting different angles. They are bending, or we can say they are refracted at different angles, so that's why we are getting different colors. And as the red light bends the least while the violet the most, that is red is least deviated and violet light is most deviated, and thus the rays of each color emerge along different paths, and it is the band of distinct colors that we see in the spectrum. So this is the band of distinct colors, that is different variety of colors are seen. So the 7 colors can recombine to give white light. See here, now this we will study in the further slides also, that these 7 colors recombine to give us white light. How they give us, that we will see in the further slides. So let's move further. Now, rainbow is a natural phenomenon showing dispersion. How do rainbow shows dispersion, that we will study in this. Let's see. Rainbow is a natural spectrum which is appearing in the sky after a rain shower. As we all know that rainbow appears after a rain shower, right? So we can see that if rainbow is an example of dispersion, that is, it is a spectrum formed by dispersion of sunlight. It is due to sunlight, not due to the light of bulb. So it is the spectrum formed by dispersion of sunlight. Now it is formed due to dispersion of white sunlight by raindrops in atmosphere. Why does it happen? It is the dispersion of white sunlight which appears by white sunlight by raindrops. The raindrops which are present in the atmosphere, the white sunlight strikes it, incidence on that rain droplets, due to which each raindrop act as tiny glass prism. So here we can say that these raindrops act as tiny glass prism because the sunlight is striking those rain droplets, those simple small rain droplets, and from that rain droplets, white light enter these rain droplets, and different colors rays refract through different angle, and from rain droplets we get band of different colors. That rain through, after refraction from that rain droplets, different colors rays are obtained, and that also at different angles, and due to which a rainbow is formed. Am I clear, students? Okay, let's move further now. So as I told you, we saw in the previous slide that the 7 colors can recombine to give white light. This phenomena we will study over here. I hope that I am clear with how rainbow is formed. It's simply nothing. When the white sunlight strikes these small little rain droplets, they refract to give us a band of different colors, and these different colors, they refract at different angles, due to which we get different types of colors, we get band of colors. Now, recombination of white light. It was first observed by Sir Isaac Newton. What did he observe? He just did an experiment. He was the first to use the glass prism to obtain the spectrum of sunlight. So what did he did? He tried to split the colors of the spectrum of white light further by using another similar glass prism. He wanted to split the colors of spectrum into white light. this colors of spectrum he wanted to split, these splitted colors he wanted to recombine them into white light. So he used a similar type of glass prism, and he placed that identical prism in an inverted position. As we can see, this prism is kept upright, and so this is kept in the inverted position, that is upside down. So with respect to the first prism, so what did he observe? So this inverted position of the prism allowed all the colors of the spectrum to pass through the second prism. So this colors of the spectrum passed through the second prism. So he found a beam of white light emerging from the other side of the second prism. What did he observe? A beam of white light was coming out, that is emerging from the second prism, and this made him give the observation that the sunlight is made up of 7 colors. So, and we can say any light that gives a spectrum similar to that of sunlight is often referred to as white light. So any light which gives us which gives us the spectrum that is similar to sunlight, as we saw that through sunlight rainbow is formed, a spectrum of rainbow is formed. So that's why he gave the observation that whether it is a bulb light or any light which gives us a spectrum, which gives us a band of 7 colors, that we will refer to as white light, that we will call as white light. So that's why we say in the definition that what is dispersion? Dispersion is the phenomenon of splitting of white light into 7 colors. Then whether it is a light of bulb or a light of sun. Okay, I hope I am clear to you. Now let's study about atmospheric refraction. I hope that I am clear with dispersion. Now, atmospheric refraction, it is due to different layers of atmosphere with varying densities. What happens in this? Different layers of atmosphere are formed and densities are varied. Densities are different. Variety of densities are there. So due to that atmospheric refraction occurs. Upper ones on rarer and layers close to Earth's surface is denser. So the upper ones are the rarer ones, and the layers which are close to the Earth's surface, the atmospheric layers that are close to the Earth's surface are the denser ones, and the layers which are upper, which are high in the atmosphere, they are the rarer ones. Now, there are some phenomena which are based on atmospheric refraction. I hope that you are clear with the concept of atmospheric refraction. See, atmospheric refraction occurs due to different layers of atmosphere. There are different layers of atmosphere, and there is a variety of densities in that layers, and due to this there occurs atmospheric refraction. We know refraction means different angles, or we can say different layers are formed. As we saw in the case of prism, the white light was refracting, due to which different layers were formed, due to which different angles were formed, different angles of colors were formed. And here also, due to the atmospheric refraction, the refraction, or we can say whenever there is refraction, the different layers of atmosphere are formed, due to which there is variety of densities. So that's why atmospheric refraction is caused. Now, and in that, the upper layers are the rarer ones, and the lower layers which are close to the Earth's surface are the denser ones. So based on this only, we are going to study some basic phenomena. So now first is the twinkling of stars and their apparent position. When light from star passes through atmosphere that mix continuously. So whenever the light passes from the star, it passes through the atmosphere. and so star is in line of sight, it is visible, and when out of sight it is not visible, so appear to twinkle. So what happens here? The starlight enters the Earth's atmosphere. Starlight, whenever enters the Earth's atmosphere, it undergoes continuous refraction, due to which it reaches the earth. It undergoes continuous refraction, and due to which it reaches the earth. Whenever the starlight whenever enters in the earth's atmosphere, it undergoes continuous refraction, and that's why we get the light on the earth. It reaches to our eyesight. Then the atmospheric refraction occurs in a medium of gradually changing refractive index, and so the atmosphere bends the starlight towards the normal. Due to this, the atmosphere bends the starlight towards the normal, and the apparent position of the star is slightly different from its actual position. In the actual position, wherever the star is, we can't see it exactly in that position. It appears a slight different from its actual position, and so that's why the star appears slightly higher than its actual position. So that's why we can observe star little bit higher than its actual position whenever it is viewed. Okay, now further, this apparent position of the star is not stationary, but it keeps on changing. The position of the star keeps on changing, and that's why the physical condition of the earth's atmosphere are also not stationary. Because the position of the star keeps on changing, the physical conditions of the earth's atmosphere also keeps on changing, and that's why the stars are at very distant, very far. They are very far from us, and they are just point-sized sources of light. So, as the path of rays of light coming from the stars goes on varying slightly, the apparent position of the star fluctuates, and the amount of starlight entering the eye flickers. What happens? The path of the rays of light which are coming from the stars, they go on varying. They differ, and that's why its apparent position also differs, and due to which the light entering, the star light which is entering our eye, that also entering the eye flickers, that also differs, it changes, and that's why the stars sometimes appear brighter, and at the other time it appears little bit fainter. Fainter means little bit lighter, which is the twinkling effect. It is the twinkling of the star. But so this is the twinkling of the stars and its apparent position. I hope that I am clear to you. Twinkling of the star is simple, that whenever the star light is going to enter to the earth's atmosphere, it undergoes continuous refraction. If it will go continuous refraction, then only the light will be able to reach our eyes. So that's why before it reaches the earth, the star light continuously refracts. It goes continuous refraction, and that's why the atmosphere but the atmospheric refraction, it occurs in a medium which is gradually changing. The atmospheric refraction occurs in a medium that gradually changes, and due to this, the atmosphere bends the starlight towards the normal. That is the apparent position of the star. The star which we can see, the starlight which we can see, or the star which we can see, is slightly different from its actual position. So the star appears, and that due to this, the star appears slightly higher than its actual position. And further, this apparent position of the star is not stationary, it keeps on changing, and due to this, the physical conditions of the earth's atmosphere also changes. But since they are very distant from us, they are very far from us, they are point-sized sources of light. And so as the path of the rays of light that are coming from the stars, they vary slightly, they differ slightly. The apparent position of the star also vary, and due to this the star light which is entering our eye, that also changes, and that's why sometimes the star appears brighter and sometimes it appears fainter. And this is the twinkling effect of the star. I hope that I am clear to you. Now, why planets do not twinkle? Another question is that why planets do not twinkle? What is the reason behind is that planets are very close to the earth. Planets are very close to the earth, and due to this they are due to which the size of the apparent image is so large, which falls outside the line of sight. They are very close to the earth and thus seen as extended sources. So if we consider a planet, we can consider a planet as a collection of a large number of point-sized sources of light. We know that planets are the collection of sun, stars, earth, everything, right? Planet, so we can tell planet as the collection of a large number of point-sized sources of light. So the total variation in the amount of light that is entering our eye, because it is a collection of large number of point-sized sources. Okay, so that's why there is a huge amount of variation in the amount of light that is entering our eye, because different types, there are meteorites, there are asteroids, there is sun, moon, stars are there. So there is a variation in the amount of light that enters our eyes, and from all the individual point-sized sources will average out to 0. So all the individual point-sized sources, if we consider star as an individual point-sized source, that will combine with the planet, sun will combine with the planet, moon will combine with the planet, so they all merge together and there becomes a variation in the amount of light. So that's why the average of the planet becomes 0, and so thereby nullifying the twinkling effect, and therefore the planets nullify their twinkling effect. Planets do not twinkle because it is a collection of what we say large number of point-sized sources. So which light should enter our eyes, that is not fixed, and the amount of light which should reach our eyes, that is also not fixed. So they all merge, and that's why the average of the planet becomes 0. So that's why it nullifies its twinkling effect. Now, why sun appears bigger during sunset and sunrise? So what happens in this? During sunset or sunrise, the rays of light travel through maximum length of atmosphere. We can say wavelength also. So what happens during the sunset or sunrise? The rays of light that are passing, they travel through maximum wavelength of atmosphere, and due to this the reflection is maximum, and that's why the apparent image, the image that is formed of the sun is closer to the eyes, is very much closer to our eyes, and that's why it appear bigger. I hope that I am clear to you. Now, another question is why sun is visible to us about 2 minutes earlier to actual sunrise or sunset. It is also due to atmospheric refraction, because when it comes closer to the horizon, when the sun comes closer to the horizon, it appears to be we can say it appears to be bigger, or we can say it appears that we can see the sun. So for a clear explanation, if I tell you that the sun is visible to us about 2 minutes before the actual sunrise and 2 minutes after the actual sunset. By actual sunrise, we mean that actual crossing of the horizon by the sun. The sun crosses the horizon. So what happens, this the actual and apparent position of the sun with respect to the horizon, the time difference between the actual sunset and the apparent sunset is about 2 minutes, and that's why the apparent flattening of the sun's disk at sunrise and sunset is also due to same phenomenon. What happens, the sun it appears, the sun comes closer to the horizon, and so that's why before sunset before sunrise it is seen earlier. Before sunrise we can see 2 minutes earlier, and it gives us a delayed sunset. I hope that I am clear. Now, Tyndall effect. We have to define Tyndall effect. The scattering of light by colloidal solution particles. So, atmospheric refraction is done. We have completed 2 topics of our today's session. Dispersion, in which we studied, which is the splitting of white light into 7 colors. We term it as spectrum. Then we studied about the rainbow. How is rainbow formed? Why is rainbow formed? Then we studied about the recombination of light, that 7 colors recombine to give white light. Then we studied about atmospheric refraction. Atmospheric refraction, it is due to different layers which are formed in the atmosphere having varying densities, having different densities, and we studied different phenomena which are related or which are due to atmospheric refraction, that is the twinkling of stars. Why do planets do not twinkle? Why sun appears bigger during sunrise and sunset? And why there is advanced sunrise and delayed sunset? That is why the sun is visible to us about 2 minutes before the sunrise and about 2 minutes after the actual sunset. This was completed in atmospheric refraction. Now we will study about another topic, that is scattering of light, in which we are going to cover the topic Tyndall effect. So, Tyndall effect is the scattering of light by colloidal solution particles. The light which scatters by colloidal solution particles. Colloidal solution you might have studied in in class 9th. So, let's study this. See, Tyndall effect is the atmosphere. Earth's atmosphere is a heterogeneous mixture of minute particles. As we know that Tyndall effect, colloidal solutions are a heterogeneous mixture. So, these particles may include smoke, tiny water droplets, suspended particles of dust and molecules of air. These all are the types of colloids, or we can say examples of colloids. Now, when a beam of light strikes such fine particles, the path of the beam becomes visible. Whenever the beam of light strikes any particles, that is particles of dust, some particles of tiny water droplets, that time the path of the beam becomes visible. You might have seen a general observation that whenever in a dark room a hole is there, and through that hole the sunlight enters in that dark room. So through the dust particles that path of the light is visible. That is the Tyndall effect. So the light reaches us after being reflected diffusely by these particles. So the light reaches us by after diffusing through these particles. It comes inside the room. The white light, the sunlight is coming inside the room through the hole. It reflects the dust particles. It diffuses with it, and then it reaches us, and through that it makes a path of light, a beam of light. And the phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. As I told you that this scattering we term as Tyndall effect, so which you have studied in your class 9th. Now, this phenomenon is seen when a fine beam of light enters a smoke-filled room through a small hole. As I told you that when sunlight enters a smoke-filled room through a small hole. in a dark room, and this scattering of light makes the particles visible, and we can even see the particles also, they are also visible. And the Tyndall effect can also be observed when sunlight passes through a canopy of dense forest. You might have seen a canopy of dense forest, means a huge forest covered with whole trees. So whenever sunlight passes through that canopy, Tyndall effect is seen. A beautiful Tyndall effect is seen, the scattering of light. Here tiny droplets in the mist scatter light. Okay, so here there is the solution of copper sulfate does not show Tyndall effect. Mixture of water and milk shows Tyndall effect. As we can see that a torch is kept, and in the figure A, that's this, in the first A part, there is the solution of copper sulfate is kept in this container, and in the second container there is the mixture of water and milk. So this copper sulfate solution do not show Tyndall effect, while this mixture of water and milk shows the Tyndall effect. So here, as we can see clearly, that the path of light is visible. Scattering, as I told you, it is the process in which light is transmitted in all directions. As you can see, this is the sunlight, and then it is scattered in all directions, and when it is incident on the particle which has greater diameter, it becomes incident on the particle having greater diameter. Then why sky appears blue? This is also something which is related to this scattering of light. So let's discuss the answer of for this question. What happens? The molecules of the air and other fine particles, as we know that molecules of air and some fine particles are present in the atmosphere, which have the size smaller than the wavelength of the visible light. The light which is visible to us, these molecules and fine particles, they have the size smaller than the wavelength. Now these are more effective in scattering light of shorter wavelengths. So what happens? They are more effective, so they scatter the light of shorter wavelength at the blue end, that light of longer wavelengths at the red end. What happens? The scattering of light is more effective in shorter wavelengths, which is the blue end. The blue end have shorter wavelengths, so there the scattering of light is more effective, and the scattering of light is less effective at the red end, which is having longer wavelengths. So the red light has a wavelength of about 1.8 times greater than the blue light. 1.8 times the wavelength is greater of red light than as compared to the blue light. So what happens? When sunlight passes through the atmosphere, the fine particles in air scatter the blue color. Whenever the sunlight passes through the atmosphere, what does the fine particles do? The fine particles scatter the blue color, which is having shorter wavelength. So it scatters the blue color more strongly than the red color. It also scatters the red color, but not that much as compared to blue color. So that's why the scattered blue light enters our eyes. Due to this reason only, the scattered blue light enters our eyes. The main reason for this is that whenever the light enter, or we can say whenever the light passes through the atmosphere contains fine particles and molecules of air. These fine particles and molecules of air, they scatter the blue light, because blue light is having shorter wavelengths. So that's why scattering is more effective in that as compared to the red light, because red light is having more wavelength, longer wavelength. So that's why scattering is not that much effective in that. and so that's why the scattered blue light enters our eyes, and then the sky would have looked dark. The sky appears dark to passengers flying at a very high altitudes, as scattering is not prominent at such heights. So those who are traveling at very high altitudes, for them this scattering they would appear, for them the sky appears dark, because at higher altitudes the scattering is not that much prominent. Okay, so this is the reason only that why the sky appears blue. So you might have observed that danger signal lights are red in color. Do you know why? Because the red is least scattered by fog or smoke. The red light, it is least scattered. Whenever there is fog or smoke in the atmosphere, red color is least scattered. So therefore it can be seen in the same color at a distance. So whenever the signal is there of red color, it is clearly visible. I hope I am clear with this question. Now another question is, why sun appears yellow? Or we can say the color of the sun at sunrise and sunset is yellow. Why is it so? Now, have you wondered any time that why the sun and the surrounding sky appear red? So how can we find out? So let's see. The answer behind this is that the violet, indigo and blue colors are scattered in upper atmosphere. What happens? The violet, indigo and blue, which are the lower colors, they scatters in the upper atmosphere, the atmosphere which is at the upper layers, and so the resultant light then comes the another color which is yellow, Vibgyor. Another color comes yellow. So when this light enters this light only enters our eyes, it appears yellow. Whenever this light enters our eyes, it appears yellow, because in the upper layers of the atmosphere, violet, indigo, blue colors are already scattered until it reaches the earth, that is till it reaches the lower layers, lower atmosphere, we get the yellow color. Yellow color reaches our eye. The scattering comes to yellow color. I hope that I am clear with this question. Then, why sky appears dark instead of blue to an astronaut? As I told you that at higher altitudes the scattering is not that much prominent. So in space no particles are present. There are no molecules of air, neither there are fine particles of atmosphere, and so that's why there is no scattering of any light. So that's why their sky appears dark. Now, why does smoke coming out of coal-fired chimney appear blue on a mist day? What happens? The tiny particles of smoke and moisture, they scatter blue color of light. As we know that whenever these tiny particles and when this moisture, they go into the atmosphere, they move towards the atmosphere, they start scattering the light which is having shorter wavelength, and the light which is having shorter wavelength is blue color, whereas the red color light have the longer wavelength. So that's why the tiny particles of smoke and moisture, they scatter the blue color of white light passing through it. So as they pass through the atmosphere, they scatter blue colored light, and that's why whenever this blue light reaches our eyes, the smoke appears blue. Now, why do motorists use orange light rather than normal light on a foggy day? Why they use orange light? So if motorists use white light while driving in fog, then the tiny droplets of water scatter large amount of blue light. So as we clearly know that whenever the light or whenever light passes through the atmosphere, the particles they scatter blue light first. So if during a foggy day there will be tiny droplets of water, plus there will be fine particles, plus there will be molecules of air, so that's why a large amount of blue light will be scattered. So this scattered blue light will keep on reaching the eyes, and that will decrease the visibility. So that's why that blue light enters the eyes and it decreases the visibility. It decreases our efficiency to see what is coming from the other side, and hence driving becomes difficult. So however, when orange light is used, it do not get scattered on account of its longer wavelength. So due to its longer wavelength, orange light do not get scattered that much blue light. As compared to blue light, orange light do not scatter that much. So that's why the driver can see that orange light clearly, and it is safe for driving. So with this, we complete chapter number 11 of our class 10th science NCERT textbook, that is the human eye and the colorful world. I hope you are clear with all the topics and all the topics are understood by you. If any doubts, you are free to ask. Thank you and have a great day.